Hi everyone, I'm going to show what will happen when put two different liquid in coaxial and triaxial microchannel in this video. The software we are going to use is Multiphysics Console version 5.5. First of all, let me introduce the geometry of the microchannel. This is coaxial microchannel, while this is triaxial microchannel. Coaxial microchannel is a horizontal Y-shaped structure as shown here, while triaxial microchannel looks like a fork as shown here. Now let us start our simulation. Click Model Wizard, click 2D. We'll choose Fluid Flow, Multi-phase Flow, Two-phase Flow Level Set for our mixing of two liquid. Then Laminar Flow is enough for simple fluid dynamic study. Click Add, click Study, click Time Dependent with Phase Initialization, and then click Done. We'll first simulate the fluid dynamic in a coaxial microchannel. The first thing we have to do is choose millimeter for our geometry. Then we'll build a rectangle. The height for the rectangle here is actually 8 mm, but here we'll use 4 mm, and then we build another 4 mm by reflection method later. The width is 30 mm. Then we choose build selected, and then we choose sketch and choose polygon, and then we choose zoom out, and then draw the inlet. We'll just roughly draw the shape and then adjust the geometry later. We adjust geometry here. Because the angle between two inlet is 120 degree, so at here the degree have to be 60 degree. We'll use trigonometry method to calculate the coordinate to build a 60-degree triangle. So at last the coordinate decide is like that. Then click build selected. Then it look like this. The next step is to build the reflection method that I mentioned just now to build another half. Click input objects, and the reflection center should be at here. And then we choose the compartment that we want to reflect, and then click build selected. Then this is another half. This is 4 mm, this is 4 mm, then add together is 8 mm. To remove the boundary, we'll choose union. Click all the compartment, remove the interior boundaries, and then click build selected. Then we will get actually what we see here. The next step is to input the material for the fluid now. First of all, we choose blank material. This is the control fluid that we will adjust the variable. We will adjust the density and also the dynamic viscosity. The dynamic viscosity is the variable for our studies. First, we will use 4 millipascal per second. This is the properties for our control fluid. The next fluid that we are going to enter is water. And then for the boundary, we'll choose BDMS. We'll choose boundary and then choose the boundary. The boundary here should be empty because this is the place where the fluid will enter. This is for the control fluid, or this is for water. And then the outlet should be also be empty. So the BDMS should be on this boundary. Next, we'll setting for fluid that we want to enter. Fluid 1 will set to be material 1, or fluid 2 will set water. Next, we should adjust the velocity of fluid that enter through the inlet. We'll click here, right click laminar flow, and then we choose inlet. This is the first inlet, and the velocity will set fixed to be 0.1. Then we right click the laminar flow again and choose inlet for this inlet, and also the velocity is setting to be 0.1 also. Then we also have to set the location for the outlet. After that, we should set the fluid that enter through the inlet. This inlet is for fluid 1, which we set just now for material 1. For inlet 2, we'll click inlet and then click in this boundary for fluid 2 that we set as water just now. Fluid 2 water, fluid 1 material 1, the control fluid. We also have to set outlet location, and then we also have to set wetted wall. Because the fluid should contact with this boundary, so we have to set this boundary as wetted wall. And then last step, we have to build the mesh for our simulation. The element size is set to be normal, and then we'll study the changes until 10 seconds. Check whether we have lost something. If not, click compute. So now this is our result. We can check what happened to fluid velocity and also pressure in here. This is velocity and this is pressure. To view what happened in every part inside the microchannel, we can choose field and then click plot. Then we can see. For velocity and pressure, red color means greater velocity. Yellow and green color shows medium velocity, while blue color shows low velocity. For pressure also, red color means greater pressure, and green and yellow color means medium pressure, and then blue color is low pressure. For volume fraction, red fluid shows presence of fluid 1, which is control fluid in here, while blue colors shows absence of fluid 1. And then the green line here shows the mixing of the water and also our control fluid. We can also see the specific value for our velocity and pressure by just clicking on the part that we want to see. Here is the value for our velocity, and also here is the value for the velocity in the later part of the mixing channel. To study the average value inside in a part, you can just right click derive values, and then choose average, and then we choose line average. But first we have to build a cut line. How to build a cut line? We click results, and then click cut line 2D, and then we decide where the part that we want to study. For example, we want to study at the x 10 mm here. We'll just key in 10 mm, and then this is -4, this is +4. Then we click plot. This is the place that we want to study. Then we go back to average value. The data set we want to study is cut line 2D1, which is this part that just now we have drawn. Then the time selection, we'll click last, and then here we'll choose velocity and pressure, choose velocity field, choose X component, and then evaluate. Then this is the velocity field at the line here, at the place here. To see the animation, we can just click animation, click player, and then we want to study velocity. We want to study velocity. Choose velocity, and then time display for each time. If you want to play in a greater interval, you can just put 1, and then click here to play. We also can choose volume fraction, and then click play. This is the volume fraction changes in 10 seconds. So this is our study for coaxial microchannel fluid dynamic simulation. To adjust the viscosity, we can just change here, and then we delete configurations here to remove the study. Remove all the tables. Now all this is new. Then we just click compute again to see what will happen when the viscosity adjusts to 2 millipascal per second. Now I'm going to show how to build the triaxial geometry, and then what will happen when simulation occur. Just click new, and then repeat model wizard 2D. Repeat what we have shown in the first part. This is our simulation. for our triaxial microchannel. The first step also, adjust to millimeter for our geometry. Then we should build a rectangle for the mixing channel here. The width also 30 mm, the height also 4 mm. Click build selected. For the inlet channel here, it's also a rectangle. They will build a rectangle. The width is 20 mm here, 20 mm, and the height is 4 mm also. Then the only difference is the position here. We have to adjust to -20. Click selected. This is the thing that we want. Click sketch polygon for the inlet channel here. Then we roughly draw. The coordinate should be like that. Click build selected. This is the shape we want. This. And then to build another part, choose mirror to reflect. Keep input objects, and then the line of reflection. Okay. Click build selected. This is the thing we want. Then to remove the boundary, click union. Click out the compartment, and then remove the interior boundaries. Click build selected. This is the thing that we want. Then repeat the same step as the coaxial. Click blank material. We also start by 4 millipascal per second. Then if we want to choose water, just search water here. Then we'll see water liquid here. This is the water. And then for the boundary, we'll just search PDMS. Then same thing, choose boundary. This is the inlet, should be empty, and this is also the inlet, should be empty for the fluid to flow in, and then outlet also should be empty to be flow out. And then we'll adjust the fluid. For fluid 1, we'll set as material 1. For fluid 2, we'll set as water. Then we'll decide the inlet. The first inlet should be the center part, and then the velocity will fix at 0.1. For the second inlet, we'll choose the right wing and also the left wing, so 0.1. We also have to set the location of the outlet. Okay, we have to decide. This is the first inlet, and then fluid 1, the control fluid, will enter through this inlet. And then for the second inlet, should be the right wing and the left wing. This is the part that water should enter, just as we have set here. Fluid 1 is material 1, here, the center part. And for material 2, water, fluid 2, water, enter through the right wing and the left wing. We also have to set the outlet location. And then also repeat, we have to set the wetted wall as the fluid will contact with this boundary. Last step, use normal element size for our mesh. Click build all. We'll study until 10 seconds. Click compute. Okay, now we get our result. And then also we can check the velocity, pressure, and also volume fraction for our simulation here. Then to view in detail the pressure in every part, you can choose field. And then click plot. Then we can see. Okay, so we can see the pressure in every part here just by clicking on it. To calculate the average value in certain part, we can just click derive value and click average and click line average. Then we can choose cut line 2D. For example, we want to examine the pressure or velocity at 20 mm here, and at x-axis which click key in 20 mm. For y-axis, here is -4, here is +4. And click plot. This is the place we want to study the velocity and pressure of what. Click line average to cut line 2D. Click last. Then we choose laminar flow, velocity and pressure, velocity field. Click evaluate. This is the velocity, average velocity at this part. If we want to check again the average pressure, click average, click line average. The dataset which choose cut line 2D one at the 10 second. Then we choose pressure, click evaluate. This is the average pressure in the line between in 20 mm here. This is the pressure. And then if you want to see the animation, click player. Yes, this is the volume fraction. You can see the animation. If we want to lengthen the display time, you can choose 1 second each frame. Then click play. If you want to choose velocity also can. It's about the same from 1 second to 10 seconds. Okay, so if you want to adjust the study, then we can just change here, then click delete here, delete configuration, then it will delete all. And then at table here, just click delete all, everything should be deleted. And then just click compute, and we can study what will happen when we change the viscosity for material, control material at here to 2 millipascal per second. So this is the content of our video. Thanks for watching.